Okay, good day everyone. My name is Afolabi and this is the concluding part of the inequality video we uploaded earlier. Don't forget to drop comments and views for us on this video. Okay, today we are going to see how we can get expressions from the number line. Of course, I've discussed how you can get the number line from the expression, but this one is quite easier than getting the number line from the expression. We have steps that have been itemized here to help you do that. Okay, the first thing you do when you are given a number line this way, it will get the expression, is that you get the number and the unknown to be in this format. Okay, get the unknown as x. For example, here, okay, I'm using this step to solve this. I want to get this expression represented here, so I'll get x box. What's the unknown? The unknown is x. Then box is the relationship between them. Then a is the given number. What's the given number in this case? -1. So we don't know the relationship between them. Then what's the next step? The next step is that I'll pick the arrowhead into the box. Pick the arrowhead into the box. Look at the arrowhead. What's the arrowhead we have here? Greater than. So I'll pick it here. Greater than. But you now observe this circle here, the null. If the null is shaded, don't forget in the earlier video I told you, if the null is shaded, then you add what? Equal to it. If it is not shaded, then you just leave it as the arrowhead. Let's look at another one. If you have something like this is 0, this is 3, and you have this, what do? You apply the same format. In the first case, you put x box, the number, what's the number? 3. Okay, then what do? You pick the arrowhead. What's the arrowhead? Less than. You pick it in here. Are we going to shade? No, we are not shading because the null is not shaded. So we only apply equal to when the null is shaded. When the null is shaded, we apply greater than or equal to or less than or equal to. If it is not shaded, then we just leave it as the arrowhead. Let's look at the third one. In the third one, we had a little bit complication. Here we have -1. Here you have 2. Then this one is shaded, and this is not shaded. Look at it. It's possible we have something like this. One is shaded, and one is not shaded. So what is the relationship between the two of them? For that of -1, it is going towards here. That of -1, the arrow is going towards here. That of 2, the arrow is going towards here. So I'm going to do both of them differently before I join them together. For the first one here, I have x box -1. For the second one here, I have x box 2. So for that of -1, where is it going? It's going in this direction, so I'll pick that direction. Then what will I do? I'll add equal to it. Why? Because it's shaded. For that of 2, it's going in this direction? It's going in this direction, so I will simply put that. Will I add equal to? No, because it is not shaded. So I have x is greater than or equal to -1, and x is less than 2. Now, most times when you have inequality graphs in this format, it simply shows that the two inequality expressions can be joined together to obtain a single inequality expression. We can write it as what? X is what? Greater than, okay, x is greater than or equal to -1. X is greater than by turning this over, and x is what? Less than 2. So we have x is greater than or equal to -1. This is, and x is greater than 2. Let's just go over this again. We have inequality graph that is joined together. Okay, the first thing I did was to separate both of them. The direction of -1 here, direction of 2 here. That's this and this. Then the next thing, I looked at it that, okay, since they are joined together, then you can also write them together this way. That means x is what? Greater than -1, and x is what? Less than 2. The last but not the least we are going to be looking at is the case of absolute values. Inequalities are absolute values. But first, let me first tell you the meaning of absolute value. The absolute value written as this is a sign. Absolute value of x means the absolute value of x. So anything you see written this way simply means absolute value of x. So if I should write -2 absolute value, it means the absolute value of 2. Now, absolute value will always give me a positive value. Always positive. Absolute value is always what? Positive. So if I'm taking absolute value of -2, I always get it as 2. I told you plus or minus will always give me plus. If I'm taking absolute value of 7, which is plus 7, it will also give me a 7. So absolute value are always given as positive. But when we have absolute inequalities now, absolute inequalities, for example, we have absolute value of x plus 1 is less than or equal to 3. Absolute value of x plus 1 is less than or equal to 3. How do we solve this? We don't know if what we have in the absolute value is plus or minus. We don't know. We don't know if it is positive or negative. Now, to give room for such ambiguity, to give room for that doubt, use a doubt here, which we don't know if x plus 1 is positive or if it is negative, then we treat it as both positive and negative. If I'm going to treat it as positive, if I'm going to treat this as positive, that means x plus 1 is actually less than or equal to 3. If I'm going to treat this as positive. If I'm going to treat this as negative, that means x plus 1 will be what? Greater than or equal to minus 3. You can see that here, sign changes. Why is the sign changing, people? The sign here is changing from less than or equal to greater than or equal to because it's what? Because I'm seeing it as negative. Don't forget, the inequality sign will change whenever I'm dealing with the negative. But it remains the same here. Why? Because I'm dealing with a positive. So you have two equations to solve. For the first one here, you transfer one to the other side. You have x is less than or equal to 3 minus 1. And that is x is less than or equal to 2. For the second one here, you have x is greater than or equal to minus 3 minus 1. And you have x is greater than or equal to minus 4. Now you have the two of them can be written as 1. Because here, x is greater than the negative value. And x is less than the positive value. So you can have it as what? You can have the answer as what? Minus 4 is less than or equal to x, less than or equal to 2. So anytime you are given absolute value of inequality to solve, the best bet is that you treat it as positive and you treat it as what? Negative. In treating it as positive, you take your value. In treating it as negative, you take your value, then you represent your equation in a number line. So unlike in that case where you have the inequality absolute value only on one side and a known value on the other side, we have absolute value on one side and known value on the other side, and you treated it as both positive and negative. Here we have absolute value on both sides, absolute value on this side, absolute value on this side. We are not sure which one is positive or negative, so we cannot do the same approach as that. To give room for ambiguity, we don't know if this is plus or minus, we don't know if this is plus or minus, we don't know. Now the only way out is to scale both sides. Even though we have a negative or positive value in both sides, once we scale both sides, it takes care of what? Of these ambiguities that we have here. Even if it's a negative number that we have here, or a negative number we have here, once we scale it, it will become positive. And if it were to be a positive number, it will still remain positive. So I will scale both sides. If I scale both sides, I have x plus 1 all square is greater than x minus 2 all square. Okay, so here, if I expand this, I have x squared plus 2x plus 1 greater than, if I expand this, I have x squared minus 4x plus 4. X squared cancels x squared. Very easy. Okay, collecting like terms, I'll take this to the other side, I'll take 1 to the other side. So I have 2x plus 4x is greater than what? 4 minus 1. Okay, so I have 6x is greater than 3. I have x is greater than 3 over 6. You can see that the sign is not changing. The sign does not change. Why is the sign not changing? Because I did not divide by a negative number. So 3 can go here. I have x is greater than half. Representing the number line, this is 0, this is half. Okay? I'm not shading it. Why? Because it's just greater than and not equal to. And where will it face? To face the same shape as the arrowhead. Remember, if you have a question with this video, you can always pause and rewind. And you can also get back to us as comments. Don't forget to hit the subscribe button on that video. Thank you.